All right, everyone. Thank you so much for making it this long to the end of our 3-day epic of data science journeys. Woohoo! Woo! So here we have our closing notes, and because Ian and I are a big deal these days, these were delegated out. So let's see how it goes. Right. So. Excellent. We have not seen these slides. They are written for us. We have many monkeys. The monkeys write the things. And yes, and we blame the monkeys when the monkey is bad. It is a PyData tradition, of course. That is why we are doing it. And
me. Hello. Hello. I'm a great presenter. Slides written to mimic our natural speaking style. Because I love having to read slides.
I'll come across as charming, goofy.
I'll come across as incredibly irritating.
Thank you so much for attending PyData London.
Yes!
What is PyData?
Well, let me...
Yeah. Many things.
Many things. A huge proportion of this meetup in this, exactly. Over 3,200 members are part of this meetup.
Global movement and global community. There's PyData meetups all over the world.
All over the world. A sold-out conference held in London, 3rd year in a row. Gets better every year.
Every year. Actually, no, I can't elaborate. I'm not allowed to.
Yeah, sorry. What happens
when the world's leading data scientists, data engineers, statisticians, ellipsis
get together?
Oh, community, right, yes, my ramble time, right. Travis opened this morning with a lovely keynote, thank you, Travis, and talked about community and the necessity of strong community. Please put up your hand if you have ever spoken at a meetup, committed to a core project, done some documentation, given a talk, done any of those community things. Put your hand up. Okay, everyone, clap these people, that's great. Everybody else, now put up your hand. Please remember that you are using things written by other people for your commercial benefit. And it'll be really good if you contributed back. So think about filing your first bug, doing some documentation, contributing to a project, giving a talk, any of those things. Just do any of those things, and it'll be great.
Or forcing other people to write the documentation, contribute to the code, pull requests, things of that nature.
This is what makes our community great. Ramble over. That one? This one?
That one.
There we go. Oh, right, and excellent, my other pet topic. Python 2 versus Python 3. Who is using Python 3? The cool kids. Yay, right, yes, excellent. Who's using Python 2? All right, okay, all right. That's kind of half and half. That's getting better every year. Don't forget, you've got a couple of years, then Python 2 is turned off. So every line of code you write in Python 2 will have to be forcibly migrated to Python 3. So you might as well stop writing Python 2 and write Python 3. Yeah. I get that there's lots of things that are in the way and that's hard, but you're going to have to translate it at some point. That's a waste of time. Stop wasting your time. Just go to Python 3. That's a good idea. Yeah, okay, second round over.
Yeah, your granddad writes Python 2. Yeah, there we go. Yeah.
I told him. Right.
I'm Expansion, Emlyn Clay.
Ian Oswald.
I'm the co-chair of this event along with Emlyn. Ian. Ah, yeah, and I see where that was going.
We aren't the only ones to thank for this event.
You'd think that we set the whole thing up, which is totally not true. We just do the on-stage bit. So we have thanks to... All of our amazing attendees.
How do you guys?
That is, sorry, we are convincing. That is, no, thank you very much, all of our amazing attendees.
Really, this is the go, right?
Yeah,
so all of you, thank you very much.
Yeah, cheers for buying a ticket. Now, off you go. Grab an extra T-shirt on your way out. There are extra ones, right? They make excellent dining wear. They provide a certain amount of insulation. If you have a kettle, and the kettle's not particularly good, T-shirt. Partners, kids, right? I mean, the
colleagues, people you work with who need a lot of
XL and L. So if your kids XXL, you've got bigger problems. Right. our 3 keynote speakers.
So Andres Fraser gave us a really nice physics talk yesterday morning. Tatiana gave us a journey into becoming a data scientist that I know inspired a lot of people. And Travis this morning gave us a wonderful overview as to how Python is moving into the whole big Java world. So a big round of applause, please, for our keynotes. I'm kind of nervous for each of these now. Right,
Over 60% of our tutorial, over 60.
Oh, yeah. We're thanking them, right? Thank you to our over 60 tutorial and main session presenters. Please raise your hands to those.
Yep.
If you're in the room and you're a speaker or teacher, put your hand up. There must be more of you than that, come surely. Right, stand up, stand up, stand up,
Yeah,
stand up,
sorry,
stand up,
properly,
stand up,
stand
stand
up
up,
properly.
stand up.
Yeah.
Teachers and speakers, stand up.
These are all the people that help make
Right,
it happen.
right, there we go. That's more like it. There we go. Right.
And this bit about slides, it doesn't end for you guys yet. We want the code, give it to repositories. I don't want your excuses, it doesn't run. You get it done.
You must all know the message by now. In the Slack channel, go to hash slides. Inside hash slides, there's a Google Sheet. On the Google Sheet, it's got your name and a blank spot. In the blank spot, you put your GitHub link and your blog post and any other bits you've got about yourself, your speaker deck and all the rest of it. We need that for the publication of the videos.
Oh, that's fine. Right. Oh, our lovely team. So Calvin, Cecilia,
Stand up,
Florian,
stand up, team,
Graham,
stand up, team, stand up.
Priya, Ruby, Slavi's not here, and Steve's not here today. There we go.
We started all of this in November, I think, so it's been going on for a lot of months. Please thank our team here and...
Our fantastic volunteers. So that's Mark.
Are they in the room? Stand up, volunteers?
Yeah, Raphael, Michael,
So
Gerhard,
some very last minute, some a little bit more
David.
planned.
Yeah.
Okay, present and absent, please thank them.
Thank you very much. Our terrific sponsors.
Our sponsors, and you've heard me go on pushing you all to go and talk to our sponsors because they're here to understand what you want to be doing.
Yep.
And to hire you as well. So it's great. Good conversations to be had. So thank you to Continuum.
Yep, they are.
Definitely, they're the reasons why we're all here. They pushed all this at the beginning. They're the reason we're doing all of this. Definitely thank Continuum. And then Channel 4, here with their hiring. There we go. There's Pada. You can't miss Pada. Pada's everywhere. Endava, is Matt and Loren in the room? Have they go? They might have bailed. They bailed a bit earlier on. Okay, in that case, I'm the semi-Endava representative. List, who sponsored the deep learning track.
Yep.
And behind...
And provide a whole bunch of speakers as well.
Well, and happy to provide the speakers. Pivigo, with their CV clinic and the PhD training. Serenata Flowers.
This was, right, Serenata Flowers, we just got a check saying we'd like to sponsor PyData. We'd love to know if anyone is a representative of Serenata Flowers and how they use Python. We'd love to know and thank them very much for their
We'd be very explicit about that.
We're going to admit we thought it possibly would have been a bit of fraud or a scam or something, but like they've,
There must be a very, very good reason behind it.
There
and we'd
must
like
be
to
a
know
very
what it
good
is.
reason.
We just don't know. We're ignorant right now. We'd like to be less ignorant.
What is the big data problem in flowers?
Optimised flower delivery service. I mean, there's some good logistical challenges there, right? Freshness, delivery time.
Capgemini for doing
Capgemini,
everything. And
absolutely.
Matt, you spoke at the end. Yeah, cheers, mate. And we are wizards for picking up part of the bar tab.
Tom's still here? Tom?
Tom? Tom's still there. Thank you,
well
Tom.
done. Tom, I'm still thanking you for my hangover.
Thank you very much.
Let's just, yeah.
Very particular special thanks to Bloomberg. Alex, you get all the praise because you're probably the only Bloomberger in the room. And, oh, there we go. You both get it. Share it. So,
Thank you very much to Bloomberg. The catering, organising the space, the security, it all comes gratis to the conference. So the money that would otherwise be spent renting a space instead goes to NumFocus to sponsor all of those projects over there. And this gives us all the toys that we need in our day jobs and in our academic work. So thank you very much to Bloomberg for making this possible a second year running.
finally, choice of adjectives, sir.
Loveliest.
Finally, the
Loveliest.
salubrious people from NumFocus, they sit in the background and are doing all of the engine of driving, all the bits that happen in the background. There's a ton of admin with doing these things. Not only that, but they deliver this on an international scale, so they have to deal with us late night calls, early morning calls, and the rest of it. It honestly wouldn't be possible with that kind of coordination behind it. They do such an amazing job. At a certain point, open source grows up and becomes very mature, in order to steward things so they don't fall apart or rot or get dependent on just one person committing to the repo and having it so that they can just continue on and become enterprise-worthy tools. Like, most people here are working with Python in their day job, part of businesses, and have those things in production. It's not really possible without this kind of organization behind it to make us have a nice stable base to work from. So thank you very, very much, NumFocus.
And almost...
Oh, sorry.
No,
Yeah.
no, that's probably a good lead-in.
Yeah, go. I just told you what NumFocus is!
Yeah,
Oh,
we're
sorry,
ranting
that's-
off here.
Oh,
Big
dear.
Emlyn, there we go. All right. Charm. You're going to hear it again,
Numfo-
charmingly.
NumFocus is the open source organization that organizes the global PyData movement. Thanks to the folks from NumFocus, whose hard work makes this and every PyData a success. That's Gina Helfrich, Lynn Brubaker, and Savannah Mercado. We speak to these people all the time. I've never met them in person, but they do an enormous amount of work. And an extra special thanks, because y'all make it all possible, Leah.
Leah.
There
Wave
you
your
go,
hand,
stop
wave
your
your hand.
hiding. Leah, have you thought of running for president? Because at the moment, the race is pretty darn bad. I think you'd make it. I'd vote for you.
And take a moment on your way out to thank Leah, because she really is the one who brings all the bits together for this and every other conference. So just thank her as you go past. She'll appreciate it. She'll be embarrassed, but she'll appreciate it.
Are you done yet? I have no idea. I didn't write these things.
We've got the stage.
Okay.
Yeah, we're not done.
Yeah, we're not done. We want
We want another one.
We want another one. Insatiable. Let us know if you want to volunteer. So we will never turn down a willing volunteer. We have all these things that get done, like, as you saw today, the volunteers who did the comparing in the rooms, there's the sort of the running around, there's getting the speakers, there's the handing out the microphones and things of that nature. We also have the meetup that goes on every month and things of that nature. Like, just as with NumFocus, like stabilizing things, we also want the meetup for itself to be completely stabilized and not dependent on just a couple people holding the thing up. So if you want to be part of that, it's really good fun. We meet up regularly. And if you like what you have here, then we basically do this every month and then a big one every year. So, come and be part of it.
There's the sign-up list on the registration desk. You put your email in, and then we'll ask you, would you like to be involved? So no commitment, just indicate your interest. All right.
Okay. Oh, yeah, we've got great feedback for this event. Here is some international feedback we want to read aloud to you.
Hey, I feel bad about this. Go on.
PyData is the best event to meet other practicing data scientists. Everyone here is actual user of the tool.
This is my favourite conference. I'm Croydon born.
I look forward to this event every year.
The keynotes were lovely.
I'll bring me mates next year.
No, you'll put on a great show.
I'm super, super glad that I traveled from Amsterdam to be here. Yes. PyData London was sufficient. PyData Berlin is in 2 weeks. PyData London is discount code to use. Precise. Factual people. We couldn't have picked a better spend our weekend. Oh, accident random. The whole sentence is one not as random elements of it. Right. Yeah, that. Right. Thank you so much.
Thank you so much.
And now, the thing you've all waited for, that you've probably missed your last train home, or your ferry, or your plane, the lightning talk.
Show.
Yes. So,
Florian.
Florian, first, mate. Yeah. Florian, mate.
Florian, leaping into action.
Yep,
There we
good.
go, leaping. Right.
Lovely. HDMI.
Move that one out. That one back to
Yeah, good.
down there.
So,
Plug you in.
Florian, of course, as everyone knows, you've got 5 minutes for the lightning talks. This year, of course, if you are overrunning in time, you are going to be assaulted by a crouched ninja. So keep it to time, people. Otherwise, it's about to get messy. Florian, how's it going? Is this a live demo?
Of course it is.
Oh God, not this again.
So we had a live demo from Florian, you know, back at one of the meetups,
18
and
parts.
it went fine.
No,
so,
stop. Okay, stop. All right. Have you got the timer?
yeah.
Are you good? 5-minute timer. No. Okay. Hard
All right,
cut off in
guys.
5 minutes. Are we good?
Yeah.
Are we going?
Yeah.
Yeah.
All right.
So, I guess apart from Python 3, the constant that was in use all the time in this conference was the notebook, and everyone's using it, and I hope you're also using Git, and you may have come across this annoying issue that if you version control notebooks, then you get all this messy output. So here I have some random notebook that just,
Time's ticking, Florian.
yeah. With some ticker data from some people's favorite company. And if I version control this, so I'm setting up 2 Git repos here, one on the left, on the right, and there's this utility called nvstripout, which you can install in a Git repo, and whenever you save something, or like you stage a file in Git, then it will automatically strip the output from the Git repo. As you all know, notebooks are stored in as a JSON file, so if we now look what we have now, so I've added the repo file to Git, and if we look at what has been staged in Git, we see that on the one without nvstripout on the left, when I save the notebook, then we can see on the left-hand side without nvstripout, we have a whole bunch of output. Whereas on the right-hand side, we don't have that. They were the same, yeah. I am in the same directory, yeah. So I've set it up. The demo gods are not happy. Yep.
You ready? Oh, no. 2 minutes, okay, 2 minutes. Sorry, wrong thing.
And now if we change this to run some other ticker, for instance, change this to Google. And save the notebook. Then you see on the left-hand side, we now have all this noise because the image is stored as a base64 encoded string in the notebook, and of course, because I've rerun some cells, the execution count has changed. Whereas on the right-hand side, the same directory, same file on disk, in my diff, I only see the 4 characters that I changed because I've only changed the Apple ticker logo to the Google ticker, and this is the only thing I really care about, right? So if you want to use this, it's on GitHub. Just search for nvstripout, or it's also on PyPy, so you can just pip install nvstripout, and then call in your notebook nvstripout -- install. And what it actually does is it sets up in your git config, it sets up this filter. This is automatically run when you do an operation such as staging or committing, and it also sets up a Git attribute that this filter is to be run for any notebook file with this IPY-NB extension. So install yourself some NB strip out and get rid of your hassles with version controlling your notebook. This is built on top of NB convert, which Thomas introduced in the session before, and I think I'm out of time, so I'll hand over to the next speaker.
So this is a GitHub repo which might be interest for package maintainers. So who is not maintaining packages or not planning to do? I'm sorry for your wasted 5 minutes. So first of all, a bit of a background. So I'm part of the AstroPy project and community, which is a community effort to develop a single core package, the library of astronomy Python, and it contains a core package and affiliated packages very similar to the SciPy ecosystem. And the one important thing that most developers are scientists, astronomers, and it's not our day job to do this. So for this, to ease up the efforts, the core package provides some kind of infrastructural help to help affiliated package maintainers to do the job. It includes documentation, tools, testing framework, a whole package layout, and templates for CI testing. And now it's the motivation for the CI helpers, which is a bunch of shell scripts, is that we are having a very complex CI matrix, all kinds of versions for our upstream dependencies, and sometimes they are broken. And sometimes, so this all started when the Miniconda pulse changed, and when I wanted to make sure all packages were working, the CI had to go to 30 repositories to just change one variable. So that's why we started the CI helpers. As I said, it's a collection of shell scripts. It's not to be used as a submodule because we going back to the same issue that going to every package and update it. But you do the cloning at the install part of your CI setup. At the moment we have Travis and Upware. So just you clone the repository and just source out the shell scripts. And what it does, it sets up a Miniconda environment and it installs the dependencies. You can control what are your dependencies, what are their versions, via environment variables like Conda dependencies or what's not in Conda or any of the Conda channels. It's in pip dependencies. You can also set versions for different packages, and it also understands dev and stable and pre-release for NumPy and AstroPy, which means that you don't have to hardwire that you want to test with NumPy 1.11 or whatever. It always goes to the latest stable. And what we do here is very important for our affiliated packages, that if there is some problem, a blocker upstream, a bug in matplotlib or whatever, then we limit the version number of that. So the affiliated maintainers don't have to care about that the documentation building is broken because of some upstream thing. One important thing is that's the link for the repo. So please, if you find it useful, just play with it. And there are working examples. You go to any of the main packages in AstroPy and ecosystem, like for the AstroPy itself, just look at the Travis YML or the Upware YML. I think it's pretty obvious. There is also a very extended README file, so yeah, use it if you find it useful. That's it.
Hi there. I just thought I'd use this opportunity to get a quick bit of publicity in for a meetup I organised with Wojtek and Sergiusz. It's the London Kaggle meetup. There's quite a few people who I've seen who have been at various events of ours as well. But if those of you who haven't joined up, please do. I'll try and give you a quick summary of what the kind of things that we do and some of the events we've got coming up over the next month. In the main, we do two types of events. We do hackathons and dojos. The next hackathon is going to be on the 4th of June. It's going to be in Rise, London, in Whitechapel, usually called Central Working. The way it's set up is we've got a big room like this one. We put a load of tables in there. We said, and each table gets given a different Kaggle contest. Oh, sorry, by the way, probably should have started. Who here is unaware of Kaggle? Okay, Kaggle is a website which hosts data competitions. So various companies host their data sets on there and say, we want to solve this contest. For instance, there's a competition at the moment where there's photos and say, can you recognize which one of these drivers is distracted? Or there's Expedia at the moment are saying, given customer information, can you work out what kind of hotel they are going to book in future as well? And there's usually cash prizes for those as well. So I sort of dabbled around a few Kaggle contests, and I want to sort of meet other people who are doing them as well. And I thought a meetup was a sort of great way of actually meeting other people. So as I said, when we actually do the hackathons and the dojos, we basically put several tables out. We say there's a different competition each table. Go there, speak to others, meet other people. I've met some really fantastic people and learned loads of great ideas and techniques from them as well. The hackathon, that's on a Saturday. It starts at about 10:30 because we don't want to get up early on a weekend, really. We finish at about 5 o'clock with a few beers as well. The dojos are usually held, they're actually always held at Ubiquity, which is just up by Moorgate as well. So they're normally the last 2 weekends of the month. They normally go quite quickly, but unless you're sort of signed up, you won't hear about them. The main thing I want to plug is we've got a sort of special one-off event on May the 17th at Code Node, which is just around the corner to here. We've got 2 talks. 2 of the guys who met up at the meetup did really well in a competition recently. They got in the top 2%. If anybody was aware of the Rossmann competition where you had to forecast sales in 900 pharmacies in Germany, and they did very well in that. So one of the guys is going to give us a talk about that as well and how he found it. We've also got a talk, a guy who up until about a few weeks ago was the #1 Kaggler in the world. He's now #2, so I'm not too sure if we want him there anymore. That's Marios Michaelidis. That's right. We actually opened this up yesterday, and we've actually been quite surprised. We've already actually filled up. However, we were given the option to actually expand the room. So if you do sign up for the meetup and you do want to come along, put yourself on the wait list, and hopefully in the next 2 or 3 days, we will get like a bigger room or more chairs put in there as well. So that's all I really want to say about the things. If anybody wants to have a chat with them and how they work, please speak to me afterwards as well. And yes, thank you very much. And also thank you very much, Ian, and everyone else for the PyData team. Cheers.
From the title. Well, what to do when you have Jupyter notebooks in Git. So the good part is that I don't think I will make it to 5 minutes, so it's going to be very quick. But, well, this is my typical research setup. I have lots of notebooks. Just for curiosity, I checked how many I had created in the last days, and this is a rough measure. I think most of them are really created by me because I should have filtered out most of the downloaded ones. So I have more or less 500 notebooks done for research. Yeah, and if you create some random data and then you commit and then you change the data and then you run a diff, you get ugly stuff and not even interactive, it's actually a PDF. And well, so I started asking around how do you people do, and I've had this question. I proposed my answer, and I'm sure there is a better answer somewhere there, but I didn't see it. And it's more or less exactly the same thing, which means it's a very good thing to do, so maybe his is better, but use it anyway. And that's it on GitHub. That's after using that. Okay, you already know it. But since you already knew everything about this, I will propose 2 things which I think are missing, and if I understand correctly, are missing from the NB strip 2. And the first is we don't necessarily hate output. That is, we don't want to commit it, but it's if you change branch and you come back, you usually like to have your output back, maybe because it took 3 days of computation to have it. Now, it's technically not too difficult, but slightly more difficult than that to keep it. And you have to store it some way. You have to map it some way to the source in a moment in which the commit didn't still assign an hash. So contribution welcome. I plan to do it, so it's not a huge obstacle from a technical point of view, but still didn't find the time. And, well, the other thing is, at least mine doesn't work with Git diff tool. if anybody of you has suggestions on why and how. I mean, I know why, because diff tool compares with the real file. So if anybody has suggestions of how to fix it, I'm interested. Also, maybe I will close the project after today. Okay, and that's it.
Yes, as I said, I was a technology enthusiast up until now. And mostly because I had a pen on there, and this pen was very essential to my demonstration, so I cannot show you this now. But I have a backup, luckily, and I've been fiddling around with my pen about 7 years ago. And I started analyzing these pen strokes, and I found these feature points here where you can see where the stroke turns and where the stroke goes into a corner. So I made this algorithm for pen strokes. And what I did with these points is I would geometrically overlay these to stored points in a database where I could get a true-false result for each pen stroke to determine whether this feature is contained within a database stroke or not. So I went on, I did this prototype for like 6 months. I thought maybe I was going to be able to sell it. Well, many illusions, many pounds spent. Later, about 4 years ago, I had a different idea. Why not, what if I could dance across a time-based series function graph? What if I could turn my function graph into something like this stroke here? And once I get to this point, I could get all these feature points here, like the turns and the corners, and I could do the same thing with my database and get a true-false result for every impulse in a time-based series. So, yeah, just to finish off this day with a little dance. Maybe I can illustrate this. So this is my time-based series. This is my delta according to my sampling rate. And now, in order to get this to resemble a stroke, I would have to analyze all the pieces of the function graph where the function graph is rising and where the function graph is falling. So as long as the function graph is rising, I would, if I can illustrate this with a dance, I would turn to the left. It's rising, right? Now, I have my direction of the previous vector, so I take my next vector and I do a step in the same direction. Now, if it's falling, I take a step to the right. So this is what it ends up, is it can be, so this is how it's constructed. Basically, you have all these little steps here, and then I go to this one here. It almost is like the pen stroke we've seen before. And yes, finally we end up here. So you would probably ask me, why not just use a function graph? So I'm going to illustrate this, like let's say you have a high frequency and a low frequency, and I'm going to illustrate this with a function graph now. So just wait until I walk off the stage, and then my talk will be finished. So I start over here, and I do it with a function graph, right? Well, sort of, we have a short frequency, right? So I do this short frequency, and I just keep on going, and now there's a long frequency. So for this long frequency, to illustrate this, okay, okay, I will just turn my foot, right? That's what you're going to see in your data with the second derivative, is how I turn my foot. If you agree, or if you can, I hope you can follow. So that was my long frequency. So I go on with my short frequency. Okay, I'm coming. So I do the same thing with my graph here, with my pen stroke graph. Okay. So what actually happens to the long frequency is that it actually accumulates little parts and pieces, and eventually it will lead me off the stage.
Thank you, Facio. You
Could
see,
you just please put my website address for before you start your next talk?
We've got a huge different machine though. Oh, okay. There we go.
Everyone can see the website.
there you go,
So
that's what it is.
GitHub spec pose and put it into the Slack channel. Okay. Yeah, perfect. Spec pose on GitHub. So thank you, Facio, and then let's take that out. Let's you on that button, yeah.
I like the
That one off.
concept of having a live demo where if it doesn't go right, you can just act it out on the stage. That's good. You know, here's my loop, right? And then I call the function, parentheses, right? And then, you know, I index my array. You've just discovered a new dance form, my friend. Thomas?
Thomas, more notebook stuff, right?
More notebook stuff, but first.
Oh, okay, well,
So lightning talks weren't enough of a challenge. I decided to try and fit 2 completely separate topics into one lightning
good
talk.
grief. 5 minutes starts now. Welcome, Thomas.
All right. So topic number 1 is the super mini lightning talk that should only take about 1 minute. Why am I showing you a cemetery? This is the tomb of the Reverend Thomas Bayes, as in Bayesian statistics. It's just round the corner from here. So if you are a big fan of Bayesian statistics, then you are in exactly the right place to pay your respects to the last resting place of Bayes, the person who invented it. It's in Bun Hill Cemetery, which is about 5 minutes walk away. So. And now to the real lightning talk that I put down on the sheet, which, just in case you're not bored of it, is yet more how to store notebooks in Git. and the punchline is, I've got 3 separate ways. So this is, number 1, is Recombine Contents Manager. So this is when you save a notebook, it will save it into 2 files, the IPyNB file without the outputs and the IPyNB something else file which has the outputs in. When you open the notebook, it will try to recombine them, so it will use the clean copy that you stored in version control as the master, and it will try to match outputs back to that and stick them in. We're actually going to do something a bit like this, sort of integrally to the Jupyter project. So we're going to have something we'll call a companion file, which will be like a zip file that gets saved next to the notebook, and you can either exclude that from Git, or you can check it into Git and treat it like a binary image or something, so you don't try to merge it. And we'll configure what you can put in there. Way number 2, NBDime, Notebook Diff and Merge. This is an experimental tool that one of Min's co-workers in Oslo is developing, and they've apparently just hired another person to help with this. So this is something that you can plug into Git, and with complete notebooks in version control, it will do nicer diffs of them and provide better ways to merge them. I think there's going to be a web interface for merging. It's still very new and experimental, but this is in active development. There are people sort of working very much on this. And way number 3 is the super crazy experimental hack, which is that, okay, so the problem with storing notebooks in Git fundamentally is that notebooks are structured JSON data. Git doesn't know about structured JSON data. It only knows about folders and text files, which are series of lines. However, you can turn a structured JSON object into a structure made up of directories and text files. So where it says sampletest.ipynb.exploded /UUID, that is a reference to a notebook and then a cell within that notebook. And you can see I have cell metadata as JSON, the cell source code as a Python file, and outputs as the appropriate types of file. and that's all in a directory which represents a notebook. And this comes with this tool nbexplode, which can turn a regular notebook into this directory and turn the directory back into the regular notebook. Thank you, everyone.
This lightning talk is just a talk, and it probably will be very fast. My background is Python in the computing, in the finance sector, sorry. Let me first explain the title. Medium data, what do I mean by that? Well, probably data that's getting too big. Data, it depends whether it's on your laptop, on your server, or wherever. I don't mean anywhere near big data, I just mean data that's getting too big. If that makes sense to anybody. Real-time analysis. Companies such as Bloomberg in the financial sector pump out a lot of data, stock prices, currencies, rates, etc. Now, we do a lot of on-the-fly calculations, but also a lot of batch processing. Most batches take about 8 hours, purely because that's the time from when you're given, when you take your end-of-day prices to when you have to deliver them in the morning. So you speed them up and up and up, and as volumes increase, functionality increases, you have to do various performance tuning, and all the data comes out very good, very valuable. And then your boss says, right, that's great batch, I want it real time. So what do you do? I've been thinking about this, and I'm developing a little system that's based on a DAG, a direct acyclical graph, messaging bus, and distributed computing. DAGs, a lot of people have taught them this weekend. Luigi, it's a little bit different to that direct acyclical graph in the fact it's a computational graph, and the inputs, whenever an input changes, then that triggers on the next calculation in the graph, rather than waiting for them all to happen before it triggers. So the beauty of the DAG is that only parts of the calculation tree that need to get calculated get recalculated every time there's a change to the input. So this speeds things up a lot. It also is very easy to make it distributed. I've been using Docker containers, so each single process is doing one calculation. It listens to the message bus, takes in the inputs, and then spits out the output onto the message bus as well. Also using Docker containers and single processes to listen for the results from the message bus and then produce graphs and charts to see the results. Again, the beauty of this is it scales very, very well for as your volume of your number of trades, your complexity of scenarios, or your portfolios or your instruments grows. So thank you for listening, and if anybody else is interested, do come to me and have a chat afterwards. Thank you.
So I don't have a lot for you I don't have a lot to present for you. In fact, I tried to put together this demo during the other lightning talks, so I hope that it works. Before I get into that, I would like to say that I think this has been an amazing event. Somehow this event gets better and better each year. I had a lot of fun. I hope that you did as well. I hope that you take a second on your way out to thank all of the organizers for this event, to especially thank Ian and Emlyn, and to thank Leah Silent from NumFocus, the people who really make this event possible. So I was up late last night, and I thought, you know, I have all these notebooks that I want to commit to my Git repositories. Wait, what's going on? I wasn't paying attention during the lightning talks. Did somebody already do this one? Okay, I'll show you something else. I had this before, but I don't think you've ever seen this. I'm kind of, every time I do something kind of wild, it takes about 1 or 2 conferences before I get tired of it. So I'm actually already tired of this, but maybe this is new for you. So I have a Python 3 installed. It's a Python 3.5.0. I haven't touched it at all. I just installed it, and I installed it when I built it and installed it when I was sitting in the chair there. This isn't like a special thing that I've set up. And I pip installed a module. I don't want to pip install the module on stage because if the Wi-Fi is a little bit flaky, then we'll get tied up in that. So it's a Python 3.5.0, and I pip installed a module that I wrote called rwatch. And those of you who are C programmers or C++ programmers are very familiar with what read watches are. It's a functionality that makes a lot of sense when you're debugging a C or C++ program. You have the ability to set read watches on pieces of memory so that every time that piece of memory is read, it triggers a breakpoint. And that's a great thing to do because sometimes you have memory mapped I/O, or for other reasons you want to be able to trigger that. Well, as a data scientist, this is also actually kind of useful because sometimes you have very large data flows, and you have millions of data items, and then one of those data items is kind of snagging the flow, like there's one malformed piece of data somewhere along the way that just blows up, and you don't know what function's looking at or what part of your pipeline, what part of your processing pipeline is falling over as a result of that data. You don't have adequate logging, or it could be for many different reasons. And there may be many steps where they're mutating the data, or there may be even multiple concurrent steps that are mutating the data, so it's very difficult to track down. What you'd like to be able to do is say, here's a piece of memory or a Python object. Every time somebody looks at that Python object, just let me have a callback. And then you could figure out every single place that your data flow either passes through that data object or something like that. So I created this module called rwatch, and when you import the module, it actually adds two things to the sys module. It adds sys.getRwatch and setRwatch. And let's look at the help text for getRwatch. It's actually not very interesting. The help text says it returns the target set with sys.setRwatch. Nothing too interesting there. And if I look at setRwatch, it set read watches for the targets. Now, if you look at this, it tells you that the targets should be a mapping of object IDs to functions. That's pretty simple. So I'll show you a really simple example. I'll just create a function that takes two arguments, a frame and an object. And all it does is it says, I saw that object at that frame in a Python program. The object at the frame. By the way, if you're doing live demos, always use short variable names, because it really helps on the typing. And I'll just return the object. Then I'll create an object, x, and I'll just set an rwatch on the ID of x and f. And then every time my system looks at x, I get a callback. That's pretty nice. And if I had a function, g, that took some variable x and returned x squared, and I looked at x, and I looked at the function called on x, you can see it shows up twice, one for when I pass it to the function, and one for when the function actually looks at the argument. So now I can kind of tell if I'm passing an argument into a function, is it ever actually being looked at? That could also be very useful. Now there's something really interesting that you might be able to immediately see from this. Oh, I'm going over time, don't worry. I have a callback, so couldn't I just do this? Oh look, I have sandboxing in Python. Because now, every time you look at the object, it raises a runtime error. You can never look at the object. And it's interesting because people always talk about sandboxing in Python as being something that's very difficult. And this may not be the perfect technique, but you could do kind of interesting things here, like you could set an rwatch on the OS module, so people couldn't look at the OS module. And you might think, oh, maybe they'll get around that, and they'll find some way to import it. So just set it on the OS string, so they can't even construct a string with the word OS in it. But that's neat. But I want to show you, and this is the last piece of it, and this is actually really wild. Nobody ever notices this or asks this, but here's what the, one neat thing about Python, and one neat thing about the kind of Python I write is I like to write it very Pythonically. So you saw that I gave it a dictionary. Oh, give me a second. Why don't I give it a default dict instead of a dictionary? So what I'll do is I'll set an rwatch with a default dict that just triggers on everything. So now I can't look at anything. If I actually did this, then here I'll just do a simple one. This is a little tricky to do, or object. There, and now everything is going to be triggered because it's a default dictionary. Now it's going to kind of blow up my program, so I'll just start this program one more time. Import rwatch from sys, import set rwatch, and I'll show you something really neat. I get the object. If the object instance is an integer, everything will be triggered on this watch. Who can answer for me? X equals 1. What's x equal to? What's x equal to? Who can get this right? Wow, that's really smart. X is equal to 16. This could really ruin somebody's day. Thank you very much. It's been an amazing event. Thank you so much.
Thank you very much, James. Thank you very much, everybody. There's one group we forgot to thank. The audio team have been running around with dongles and all sorts of things, being really, really awesome, making it all work. Please thank the audio team. Right, if there's any lost and found, it'll be in the cloakroom just around the corner. Speakers, go into the hash slides channel. Don't drop your slides in there. Go to the Google Sheet and link them in there, please. PyData Berlin, the discount code is still available. PyData London, 2 weeks' time. PyData Berlin, hands up, PyData Berlin. Oh, there's more of us now. Excellent, great. We want a few more of you coming out, okay? PyData London is the discount code. That's it. And no. And that'll be it. There. All right, thank you very much, everyone.
Thank you very much, everyone.